All right, folks, it is the second day of school, and I want you to open your books to your stamp page, which should be immediately inside your book here. Last class, I told you this would be the date for your stamp, but I did not mention what the actual stamp was for. Ms. Woodlock may have already given you instructions on this, but if she didn't, then I'm going to go ahead and say this will be pages 9 to 13, which is basically that introductory activity that we did last class. And again, if Ms. Woodlock told you something different, just do what she said and ignore what I just said. Today, which, again, depending on if it's an A day or a B day, is either the 24th or the 25th. Today, your stamp is definitely going to be for the lab we are doing from pages 25 to 29. Remember that these stamp grades are going to be how you get your daily grades for the unit. You'll only get a 4 for these if you fully participate in everything and the vast majority of your answers are correct for anything that you answer. So keep that in mind. Getting zeros means you're eventually going to have a 0 or close to a 0 in the grade book if you get all zeros the whole page down. So just something to think about. And once you're done labeling your stamp page, please flip ahead to page 25. We're going to skip some stuff. Skip ahead to page 25, which looks like this. And what I've actually written at the top here is that I want you to watch a video on lab techniques and safety before we go through this page. So I'm going to ask somebody to please pause my video. There should be a link to the a link in the description of my video to this video. So follow that link, watch this video, and if I somehow manage to not link it where you can find the link, this is the title of the video I want you to watch, so you can still find it. Pause my video, watch this video, and then come back to my video. All right, pause it. Okay. So you've now watched Hank describe some basic lab techniques and safety to you. Let's talk about some more specific safety equipment that you're going to be using in the lab we do today. Some of these I am positive you're familiar with, and some of these I'm going to guess you probably have not seen before. These guys right here, everyone should know these. I assume we all know these are safety goggles. And their purpose is to protect your eyes. There are going to be times this year when we do labs where one thing or another could damage your eyesight. I think Hank mentioned in the video something about your eyeballs melting, and that literally is a thing that could happen with some of the chemicals we're going to use this year. So anytime I tell you to put your goggles on, it is so that you don't go blind. And the same with Miss Woodlock. If she tells you to put your goggles on, it's because she doesn't want you to go blind. So put the goggles on when you are told. And yes, you will have to wear goggles today. Additionally, there's not a picture on here for this, but if your hair is long enough to go in a ponytail, you will have to put it up in a ponytail for the lab we're doing today. If you don't have a ponytail holder or rubber band, I'm sure Miss Woodlock can find in my desk a normal rubber band, normal one, that you can put your hair up in. If that doesn't sound fun to you, then maybe you can find a friend who can lend you one that is made for hair. But either way, your hair is going up. If it's long enough to fit in a ponytail, it's going in one. Okay, these next two, here and here, these are, I'm sure most of you know, test tubes. And they are made to hold small amounts of substances for observation. So we don't measure with a test tube. There's no markings on them to measure with. We just like using them so we can use small amounts of stuff and see what's going on with them. And then this thing right above it is called a test tube rack, which, surprise, holds multiple test tubes upright so that they don't fall over and you don't have to worry about spilling stuff. Some test tube racks also have the ability to hold your test tubes upside down after you clean them so that they can dry. And this next one down, it's not showing up super dark on my video, but obviously it's on your paper right in front of you. This is called a pipette. There are lots of different kinds of pipettes. This is just one kind. We use disposable pipettes, but this is a public school and we don't have a lot of money, so you're not going to dispose of them. Do not throw the pipettes away. Don't ever throw pipettes away in this class. We will reuse them because we don't have a lot of money. Don't throw them away. So this is a pipette. You use it to hold or transfer, usually, well, I should say hold for transfer. Yeah, hold for transfer small amounts of liquid. They do not work with solids or gases. It's got to be liquid. And you use them just to move stuff. Some pipettes you can measure with. The disposable ones, some of them have markings, but you should not use those for measurements. At best, they will just be an estimate. The disposable ones are not for measuring. Even if they have markings on them, those are not accurate markings. They're estimates, bad estimates at best. This next thing is several pieces. It's called, you have a ring stand right here. The ring stand is this part that I'm going to highlight in yellow. That's the ring stand. Then you have a ring. That's this pink part I'm highlighting. That part is called a ring. And then sometimes they kind of redrew it out to the side here. But it's usually like connecting right there. And it's called a clamp. And it basically just keeps the ring clamped on to the ring stand. And I'll highlight that one green. And basically this entire apparatus overall is made so that you can suspend, that's a fancy word that means like hold over. You can suspend a funnel over a flask, or sometimes you use it to hold a flask over a flame. So basically you put something in the ring and you can raise and lower the ring to certain heights so you can fit something else under it. So in this lab today you're going to have a funnel inside the ring. The ring will be raised up a little higher and then you'll have the funnel sitting up here and there will be a beaker under it to catch what's coming out of the funnel. This next thing is called a scupula. And I'm going to give you one guess. What do you think a scupula does? It scoops. It is used to scoop small amounts of solid now. We don't use this for liquids or gases. We use it for small amounts of solid. pretty straightforward. I'm going to move it sideways a little bit. This next thing here is called a watch glass. You're going to use it to, go figure, watch stuff. So I'm gonna move my paper over a little bit more. Hope that's okay. You can always pause the video or go back if you didn't finish writing this down, but I'm gonna move it over. A watch glass holds substances for observation. It kind of looks like a giant contact lens. It's not necessarily super easy to tell from the picture, but it's kind of like a small little shallow bowl, very shallow bowl, and it's clear. So you can put stuff in it and you can watch the stuff that's in it. That's why it's called a watch glass. This next one, you've probably seen little droppers like this before. At your doctor's office or at home, you might call those eyedroppers. Here, I'm not going to call them eyedroppers because we do not put things in our eyes during chemistry labs. These are just called droppers and dropper bottles. And we use droppers and dropper bottles to hold and transfer small amounts of liquid. And I'm going to teach you another new word. Are you ready for this? Here's a new word. We hold and transfer small amounts of liquid dropwise. What do you think dropwise means? If you said 1 drop at a time, you are correct. So with a pipette, which was what we had up here, you can also do dropwise with a pipette, but often you will just use a pipette to do a whole squirt all at once, but you could do it dropwise with a pipette. With a dropper, they are specifically designed that you want to only do 1 drop at a time. These things, they look like tweezers. They are not. Do not call them tweezers. These are called forceps. Tweezers are what people use to pull splinters out of their fingers or hairs out of their face. Forceps do not touch that part of your body that way because, again, this is a chemistry lab. They're going to have years and years of like rust and crud built up on the edges, and you do not want those all over your face or digging into your skin to get a splinter out. Do not use forceps like tweezers. They are not tweezers. But we do use them to transfer, I'm going to say medium-sized solids. They don't really work if you have like something really powdery, like baby powder or whatever, then you would use a scoopula. But if you've got something that's like kind of pebble-sized, you can use forceps for that. This next one, the picture just kind of looks like a stick. This is a glass stir rod. It is made of glass, which means you need to be careful not to break it, and you need to make sure that it doesn't roll off of your countertop. So when you are at a station that has a glass stir rod, please make sure it's always placed where it can't roll off the table and fall on the ground and shatter. So put stuff on either side of it so it can't roll. Like you could do, I think most of the stations that have a glass stir rod have like beakers and stuff, so you could do like if this was your stir rod, you could put like a beaker here and a beaker here, and then it won't be able to roll off. It'll just hit a beaker and stay where it is. So please make sure you don't break the stir rods. Guess what they're made for? To stir stuff. Go figure. Okay, this guy right here, I'm sure you've seen and used these before. These are called beakers. They are used to hold, mix, and transfer substances, and it could be liquids or solids for these. And I'm going to say something that might blow up some of your minds here. Most beakers have markings on them for measuring, but you should not ever, ever, ever measure with a beaker. Those markings are really bad. They could be off by as much as like 50% or more. Do not measure with a beaker. If you have ever had a teacher who made you measure with a beaker, then they either did that because A, they also worked at a public school and did not have money to give you real measuring equipment, or B, they didn't know what they were talking about, or C, they were just lying to you to make their own lives easier. Do not measure with a beaker. Don't do it. That's terrible. They will not give you good measurements. Those markings are there just to trick you, basically, or for teachers who work at poor middle schools to be able to trick you into thinking you can measure something when really those measurements are basically meaningless. Don't measure with a beaker. We're going to measure with graduated cylinders instead, although I don't think this lab actually has you measuring anything with a graduated cylinder, because I don't think this particular lab, any of the stations, have you measuring anything. But in general, as we progress through the year, you will use graduated cylinders to measure. Never measure with a beaker. I will look at you like you're an idiot from my house where I am with my baby right now. I'll just know. I have a sixth sense. Oh my God, someone just used a beaker to measure. What a moron. That's what's going to happen. Don't measure with a beaker. Yeah, you can't wait to meet me, can you? I sound like such a pleasant person. Okay. This last one is a funnel. You may have something like this that you use in your kitchen or in your garage. A funnel is used for transferring liquids to avoid spilling. And you can also use them for filtration, which is what you're going to do today. When you're done writing this, turn the page, or maybe look at the next page. Again, my book is just paper. And if you're not done writing this, you can pause the video right now. But I'm going to move my page. So let's look at your lab. This lab is a lab with a lot of stations. So each station has its own data table chart. You're going to describe what your materials look like before the change happens. You're going to describe what your materials look like after the change happens. These need to be one complete sentence in each of these boxes. You're going to decide if you've witnessed a physical change, a chemical change, or both, and then support your claim with reasonings, which, again, need to be complete sentences. Part of your stamp today is going to be, did you use complete sentences, or did you just write 2 words here, 2 words there, 2 words there? If you're not using complete sentences, you're not going to get a 4 for your stamp. We are going to do some preliminary definitions on what is a physical change and what is a chemical change, and then I will end the video and Ms. Woodlock will talk to you about each individual station before you get to the lab. So we are going to talk about physical and chemical changes in more detail on a different day, but the short version is that a physical change is a change where all substances keep their identity So it changes what they look like, but not what they are. Kind of like you getting a haircut. That doesn't change who you are, it just changes what you look like. A chemical change is a change where at least one substance gets a new identity. Generally, this will mean that they change both what they look like and what they are. So this would be like, instead of you getting a haircut, which doesn't change who you are, this would be like if you went through like witness protection and they gave you a totally new identity and they said, your name is no longer Mary, your name is now Calpurnia, and instead of being a high school student, you're a dry cleaner. Like that's changing what you look like, because they would give you some kind of makeover to make it harder for the murderers to find you. And it would change who you were. Those examples may or may not be great analogies. I'm a little brain dead because as I record this, I've had one day off of school. So I'm sure Miss Woodlock can do better. She's nice and fresh. Okay, at this time, I'm going to end the video, and Miss Woodlock's going to talk to you about the lab.